Good evening. Welcome to MATLAB Masterclass Series Day 19. Before we go into the session, first I would like to thank IIT Mumbai for their cooperation and for their support for this program. I would also like to thank you. Thank you for your participation and thanks for coming. Thank you for your commitments towards learning. I once again welcome you to this session. Today is Day 19. So today's topic is Arduino Programming using MATLAB. This is quite different from the previous topic. So far we have covered up the image processing and basics of image processing and the deep learning, machine learning. So this is something related to controller side. So it could be used for designing autonomous robots. Like if you want to do a robot kind of thing, then this Arduino programming using MATLAB could be useful for you. As autonomous robots is gaining more and more traction. And nowadays, they will be they are using their application is vast wide. So this program could be useful for you. So far, we have completed 18 days. We have completed some basics on MATLAB and some basics on image processing, video, and computer vision and medical image processing. As well as we have completed the graphical user interface and app development, app designer. And we also completed machine AI thing like machine learning, deep learning, and fuzzy logic, neurofuzzy logic, and some applications like face recognition, object detection, and segmentation and compression techniques. So today's topic is it's quite different from this previous topics. Arduino programming using MATLAB. Let us get into the session. So what is Arduino? So Arduino, Arduino is a company which manufactures both hardware as well as software. And if you take the specialty in Arduino is the IDE, like Arduino IDE. It is quite similar to MATLAB as all the majority of the applications or majority of the libraries are in, but no need to worry about the registers. For example, if you're writing a code for if you're writing a code in a microcontroller, so you have to take care of the registers and everything. But when you go for Arduino, you can concentrate on your own application. So no need to take care of registers. For implementing a simple UART concepts, you can just use a single line of command to print it in a UART. Whereas when you go for a traditional microcontroller programming, you have to you need to know how UART works, and you have to make the pin high and low on the timing signals. You have to gone through the timing signals. Everything but in Arduino IDE there is no such thing. You could directly concentrate on our application. So you could implement applications if you want to implement interface like I2C or SPI or even ultrasonic sensors. Most of the libraries are inbuilt, so you could call the libraries and you could easily make it on a single line of code, and you could complete the application faster than the traditional microcontroller design. Even a lot of microcontroller manufacturers are switching to this IDE. Like if you take Texas Instruments, they released an IDE called Energia, which uses a similar kind of thing. All the Arduino source code will be compatible with in Energia IDE, where you could program MST430 microcontrollers. So Arduino, so the controller what Arduino uses is the AVR microcontrollers, is from Atmaga series. And so that's all about Arduino. It's the core strength is on their software, their IDE part. Okay, so the boards they have they have Mega and they have LilyPad series, and they have Nano and Mini series. So is the mostly wide used board. So Mega is if you want more number of GPIO pins, and if you need more speed, more speed, then you could go for the Mega version. It will have more number of GPIOs, 2 UARTs and SPI, I2C, as well as more speed. So Mega. LilyPad is mostly for textile electronics, wherever textile kind of thing. Mostly is for textile electronics. A miniature microcontroller like Nano and Mini are the miniature microcontrollers. If you have a very simple application and with compact size, if you need a compact size, then you could go with Nano or Mini microcontroller boards. So these are the boards which was supported by Arduino. So the features of Arduino, we are going to see demo on Arduino Uno today. If you see the features of Arduino Uno, the board has a USB port and the power input port. The board can be powered by either any of the USB port, or it could be powered by the power input port. You could use a 5-volt jack, or you could give a USB cable. It can be powered by a USB cable from the laptop. So it also has, if you want to give power supply for the sensors, then it has a power supply pins, which I have marked red here. And it also have an analog input pins where you could give analog directly give the temperature sensor and analog sensors to these pins. And if it also has a digital pins, digital pins and the PWM pins, and also the serial port pins like TXD and RXD pins. Apart from that, it also has a in-circuit serial programming. If you want to program this Arduino through a serial port, then that is also possible by doing this with this pin. No need of any external microcontroller, any external programmers. So this board can be programmed using a USB cable from the Arduino software. So through the in-circuit serial programming. So this DIP IC is the microcontroller part, and this is the crystal to the board, and this chip is FT232. Like that's a serial port to USB converter. So you could use this board either as a USB to serial converter, or you could use this USB port for programming, and it can also be used for serial port programming. Okay, so these are the features of Arduino Uno. So coming to MATLAB, like Arduino support with MATLAB, like Arduino was supported by MATLAB by in two ways, either by M-file programming and another is through Simulink option. And they also have a support for ThinkSpeak, support for desktop MATLAB, where ThinkSpeak is a cloud where you could send the sensor data to the cloud, and you could write the program MATLAB coding on the cloud. Like for example, if you have 100 sensors, and if you want to send the 100 sensors data to the cloud, and if you want to run a machine learning algorithm for prediction, that is possible with the ThinkSpeak cloud, where you could have a machine learning algorithm on the M file and machine learning or deep learning algorithm on the M file. You could collect the sensors from the Arduino and you could send it to the ThinkSpeak cloud, and you could process this prediction. And if you want to generate an alert, if you could also generate an alert, you could send an email, you could send an SMS, or you could send it on WhatsApp. So that is possible with the ThinkSpeak cloud. So apart from this, like MATLAB will by using MATLAB, you could accrue the analog and digital sensor data from the Arduino board. You could also control devices with digital and PWM control pins, and you could also control motors like a servo motor or a stepper motor or a DC motor, that kind of thing you could do. And you could also access I2C and SPI protocol here. And you could also communicate the board through USB cable or through Wi-Fi option. So remote programming is also wireless programming through wireless is also possible. You could go for wireless programming, and you could also add custom add-ons. For example, if you have a custom library for a ultrasonic sensor, or for a servo motor, or for any kind of sensors, if you have a custom library like CAN or something else, you could add the custom add-ons to the MATLAB. So that is also possible. You could add the library to the MATLAB. And it could also read the CAN messages, like CAN is supported through MCP2515 IC, which is the microchip IC from the, that is also possible. Like you could read the CAN protocols over MATLAB. So it's a better tool for data visualization. So the reason why you go with Arduino programming and MATLAB is the mathematical modeling, whereas you could also do the same thing on the Arduino IDE. But if you have a complex mathematical model, then it is better to come with MATLAB, where you could implement the algorithm part on the MATLAB, and you could generate the code, and those code can be downloaded to the downloaded to the Arduino version. So that's the main support of, that's the main thing of programming the Arduino and MATLAB part. It's a mathematical modeling. So Arduino, like MATLAB also provides, Arduino and MATLAB like combined together, they use a provided kit called the Arduino engineering kit, like where you could evaluate the algorithms. Like for example, this kit has a self-balancing motorcycle and a mobile rover for path planning, and path planning robot can be path planning, as well as you could also generate paths, and drawing robot, which is used to like draw it on a whiteboard or paper like that. So these are based on like on algorithm basis. Like it involves to you could implement a complex algorithms on Arduino. So which is quite tough when you go with writing the code on the Arduino IDE process. So to set up, the first thing to set up this Arduino is to you have to install the hardware support package for MATLAB. I told you that it has two options. Either you could go with the Simulink option, or you could go with the MATLAB option. So first, there are 8 steps involved in this M file. There are 8 steps involved. First, start the MATLAB, then go for the environment section, go for add-ons, and click hardware support package. It will start the add-on explorer window. There you have to search for the Arduino MATLAB support package for Arduino hardware. Then you could log in, it will ask for a MathWorks account. It is a free account you could create, and you could download this, you could accept the process, then it will automatically package and it will download the install. So after that, Arduino package will be installed, then you could open for Arduino. I'll show you where to go on MATLAB. I'm going to open MATLAB. So in this MATLAB window, just go for home and then click add-ons, get add-ons, click get add-ons. So you got add-on explorer here. So here you could choose a search for Arduino. You have an option called MATLAB support package for Arduino hardware, which I have already installed. You also have a Simulink support package for Arduino hardware. I have not installed this. So you click this one. It will ask for a login option. So already I have installed, so it is there. So if otherwise you have to give login and you have to install the option. So once you install the option, like you will get this window where you could connect the Arduino board and you could check for the option. So if I'm going to connect an Arduino board over here, so I'm going to connect an Arduino. So once I connect the Arduino, so you could see in the command window that Arduino Uno is directed. This device is ready for use with MATLAB support package. We use this device with Simulink, install Simulink support package. Okay. So once Arduino is directed, then it's okay. The installation of this support package has done correctly. Okay, so to test it on MATLAB, you could open MATLAB and command window. If you type A equal to Arduino, like if you check it on MATLAB, just go for MATLAB and A equal to Arduino. This will return an object to which component has been connected. So I'm going to clear. Okay, I'm going to clear and I'm going to execute it again. Okay, cleared. So first, I'm going to open the device manager, and I'm going to check to which component has been connected. So comport file. So I'm going to run A equal to Arduino. Okay. So if you check now, you will get this properties. It is connected to port COM5, and the board type is, these are all the available pins, D2 to D13 and A0 to A5. So available digital pins is D2 to D13 and A0 to A5. Available PWM pins is D3, D5, D6 and D9 to D11. Okay, these are all the PWM pins. Available analog pins is A0 to A5 and available I2C bus. Like these are the libraries. Currently I have installed only ultrasonic library. So this object you will get. So if you get this object, then the installation part is done. Okay. So today lessons, these are the lessons which we are going to cover up today, like blink LED, push button, and reading analog value. Like we are going to interface a part meter and we are going to see the value here, and the reading analog value in input pins. I'm going to interface a part meter as well as an LED, and we are going to increase the brightness by using the PWM. And fifth is to interface the buzzer with the Arduino, and sixth is to interface the temperature sensor with Arduino, and seventh is the servo motor. So these are the demos which we are going to see today. So I have a limited USB ports. So what I'm going to do is I'm going to switch on the camera now, and I'm going to connect the camera to the board. so that like you could view what is happening on the board. I'm going to connect the board, and then I will explain the code over here, and we can go to the demo. We can go through the demo one by one. So I'm going to switch over the camera. So kindly wait for a minute to switch over the camera. So thank you. Let us go for the demo. So I'm going to connect LED now. So this is the connection for connecting the blinking for LED. So I'm going to connect the resistor to ground. Okay, resistor to ground. I'm going to connect resistor to ground, and I'm going to connect an LED. Okay, the IO is connected. I'm connected to D10. So first I'm going to initialize the Arduino. Then I have written a simple for loop for I equal to 1 to 5. Write digital pin will write 1 to the digital pin D10, and I'm giving pass command for 0.5 seconds. And then again I have make it to 0, and I have given pass command n. So this will blink the LED for 5 times. So I'm going for MATLAB now. I'm going to create a folder. Copy the path. Open MATLAB. Change the path. Type edit to open the new file. So I'm going to declare Arduino object. Before that, I'm going to clear. Okay. So write digital pin. Help, you just type help write digital pin. You get a sample code. Type help Arduino. Okay, write digital pin. You click write digital pin. You get a sample code here. So copy this code. I'm going to, this object is A, and the pin value is D10, and the value is 1. Okay, so I'm going to give a pass command for 1 minute, and I'm going to value is 1. This I'm going to pass it 0, and I'm going to give again a pass command. So this will be the while loop, while of 1 for I equal to 1 to 10. Okay, end. So save the program. I'm going to save this as example 1, and I'm going to run the program. Okay. So I'm going to click run. So it is creating an object. So if you check now, the LED is blinking now, right? So I'll explain you the code one more time. So you can see that LED blinking now. So I will explain the code now. I'm declaring an Arduino object. Then I'm opening a for loop for I equal to 1 to 10. Write digital pin will write 1 to the pin D10. Pass 1. I'm connecting this LED to D10, and again I'm writing 0. After a delay I'm writing 0, then again I'm introducing delay. So this will continue for 10 times, and it will switch off. So this is the LED code. Let us go to the next experiment. So the next experiment is switch. Okay, the next experiment is switch. I'm going to interface a push button here. So I have a push button here. So I'm going to disconnect this one. I'm going to connect this as D2. So this push button, I'm going to kind of 10K resistor to a VCC. Okay. This to D10. Okay. This to D10. Okay. So this is the connection. I'm going for MATLAB now. So I'm not going to declare the Arduino object. So edit. I'm going to use the same one. Okay, the object is stored already here, so I'm going to use the same object. Instead of this, I'm going to read pin. I'm going to write a simple while loop for I equal to 1 to 100. Okay, and I'm going to read the digital pin. So you just type help Arduino. You will get the syntax. You could copy the syntax from here. Read digital pin. Okay, so copy this digital pin. Okay, this is A and this pin is D10. I'm going to read D10. So just I'm going to display the value, disp of value. Save the program. X2. I already read the Arduino, so it is stored in A. So I'm going to use the same object file. Else it will take some time. Save the program, run the program. So I'm going to give CLC here. Okay, save the program and run the program. This is D2. Let me give this in D2. So otherwise we have to clear. Okay, so now I'm going to press 1. So instead of this, I'm going to give this as while loop, while of 1. Okay. Save the program, run the program. So if I press 1, it will be 1, otherwise it will be 0. Okay, so this connection is not proper. So if we give this connection proper, like so if you check the output over here, I'm pressing button now, it's 0, 1. Okay, I'm pressing button 0, 1. So this is status. So the status is displayed on the command window. Okay, 0 and 1. So I will explain the code one more time. So it has been already like A has the Arduino, like we have already stored the object here in the previous code, A equal to Arduino. So I'm going to read a digital pin. So read digital pin is the command, and I'm going to digital pin D2. So this is the value, and I'm going to display the value here. Okay, so the connection has been done as per the schematic here. Like I have a 10K ohm resistor connected to VCC, and this is connected to pin 2, and this is the button, so push button, and this is the other end of the push button is connected to ground. So this is interfacing push button with Arduino. So the next demo is on reading the analog value, how to read the analog value from the pot meter. So First, I will go for the connection. So my pot meter has orange. My pot meter has orange, yellow, and green. So yellow is the. So I'm going to disconnect this one. So yellow is like the output. So I'm connecting the output to A0. Okay, I'm connecting the output to A0, and this has okay, one it's ground and VCC. The other end I have to connect to ground, the VCC part. Okay, so I'm going to MATLAB now. I'm going to break this loop first. So edit to open a window, save as example 3. Okay, so now I'm going to like already it has been read. Okay, so just I'm declaring a variable called time equal to 200. Okay, so it reads the voltage. Read voltage will read the voltage from A0, and this voltage will display the voltage here. So this loop will decrement and passes a command for delay. Save the program, run the program. Okay, this voltage you could. I'm going to round. I'm going to keep a breakpoint dbqt. Okay, and I'm going to like round the voltage. Round the voltage here. Analog value. Before I'm going to clear this one CLC, so run the program. So this is a value. Now I'm going to rotate 3, 4, 5. Okay, the maximum value is 5, 2, 3, 2, 1, 0. Okay, so this is 0, so it will vary from 0 to 5. So I have rounded off, so there will not be any float value. So it will give you only the fixed value 0 to 5, 0, 1, 2, 3, 4, 5. So I have connected a pot meter to an analog pin A0, okay, to an analog pin A0, and another two pins are connected to VCC and ground. So now I'm varying this voltage. So in this code, like I have declared a time equal to 200. I'm writing a simple while loop. Read voltage is the command which will read this voltage from A0 pin, and I am going to round off this voltage, and I have display the voltage in the command window. So this loop will continue till the time get reduced to 0. Okay. So the next program is on analog value with varying LED. So varying LED. So this program will give you the example using PWM. So first I will explain you the code here. Then we can go to MATLAB and we can check out. The previous example has a potentiometer. So we have displayed the potentiometer value on the command window. In this we are going to pass the voltage to another pin. So such a way it creates a PWM voltage, and this PWM voltage has been written to a pin called D11. So I'm going to connect an LED to D11 pin. So I have a LED here. I'm going to connect the LED to D11 pin. So black I'm going to connect. I have 3 pins here. The black I'm going to connect it to ground. Okay, and white I'm going to connect it to 3.3 volt. The brown is I'm going to connect to D11. Okay, So I have connected the LED and I have connected the pot meter. So now I'm going to vary the, I'm going to write the code. I'm going to use the same code. Save as example 4. So if you check the code, I have read the voltage and I have applied the PWM voltage here, right? PWM voltage of A. This is D11 is a pin and this voltage I am passing to that value. Display voltage time equal to 1. So this I'm going to increase this to 500. So run the program. So now I'm going to vary this potentiometer. Like if I vary, like you could see the difference. You could see the difference of the brightness. Like I'm going to vary. Okay. So here we have connected the potentiometer and an LED, and we are varying the brightness by using the potentiometer. So potentiometer is connected to A0 pin, analog voltage, and this LED is connected to D11 pin. And I'm first reading this voltage of the potentiometer, and I'm using this voltage to write it to this. I'm creating a PWM voltage by passing this voltage what I have read from the potentiometer. Then I'm going to blink this LED based on this voltage. So when I vary, like it will blink. It will vary the intensity. Okay. So this I will break it. I will break the loop. Dbqt. So I will explain the code one more time. So if you check here, like we have declared the Arduino and I have made a simple loop, while loop, and here like I have read the voltage of A. A is Arduino object and A0 is the analog pin, and write PWM voltage to D11 and this voltage and display voltage and time equal to time minus 1. Okay. So the next experiment is on buzzer, like how to interface buzzer with Arduino. First I'll explain you the code, then we can go to Arduino and we can connect the buzzer. So here like I have configured an Arduino. I have connected a push button. So push button pin as well as the I have connected the buzzer to D2, D11 and the push button to D2 and have changed the duration. Okay. I have introduced a pass command. So whenever I press the push button, the buzzer gets switched on. So first we'll make the connection. So I'm going to use this one. I'm going to disconnect. So I'm going to connect this to ground. Okay, now I'm going to connect the buzzer. Here I have 3 pins. Gray I'm going to connect data. I'm going to connect this to D10. D10, and I have yellow is ground. Okay, I have connected. So I'm going to copy this code. So I'm going to create a new program. Save the program as example file. So I'm going to comment this Arduino, comment on this clip because already we have an object. So I'm running the program now. As is connected with D10. Okay. First I'm checking buzzer. Okay. Okay, so buzzer is working. So now I'm going to this is D10. I'm going to check the switch is working on it. Switch is D2. Okay, switch is D2. Okay. So now I'm going to save the program. I'm going to comment these two lines, comment, save the program and run the program again. So whenever I push the button, like the buzzer gets sounds. Okay. So I will explain the code one more time. So here I have read an Arduino. I have configured the pin, and I have write a simple while loop. I'm reading the digital pin. And this writing for digital pin will read the data, like that will be the status of the push button. So if the status is 0, like it will switch on the buzzer, else it switch off the buzzer. Okay, this is an example for a simple interface with buzzer and the push button. The next coding is on LM35, how to read a temperature sensor. I'm going to disconnect. I'm going to disconnect and I'm going to connect the LM35, like LM35 sensor. Okay, so this is LM35 sensor. Red is the VCC and black is the ground and brown is the data. Data I'm going to connect to A0. Okay, I'm connecting to data to A0 and this to VCC 3.3 volt. Connect to ground. Okay, so I have connected to the VCC. I have connected to the temperature sensor. I'm going to copy this code. And I'm going to create a new file. I paste the code here. So I have already read the object. So I have comment these two lines. So it reads the voltage example 6. Okay, example 6. So I have already read this voltage here, and I'm converting to Celsius, and this round. This is to round off the temperature, and this is to display the temperature sensor. Okay. So I'm running the code now. So if you check, the temperature sensor has been displayed here. So there is some slight variations, like actually it should be 32 to 36, but 28, 29 depends upon the, it is due to maybe the temperature sensor maybe could be a problem over here. So this is the simple code to read temperature values from the LM3 phase sensors. This is an analog temperature sensor, so it has to be connected to the analog input. So A0 is the analog input. So I have connected the data pin to the analog input, and VCC and ground I have connected, and I have downloaded the code. So that's all about temperature sensor. The next coding is on servo motor. So I will disconnect this temperature sensor. So I have a servo motor here. I have a servo motor. Okay. So this servo motor, like the orange pin is data, and the red is VCC, and the brown is ground. So I'm going to connect the VCC, and the brown is ground, and I'm going to connect this to data pin. Data pin I'm going to connect to D4. Okay. I'm going to connect D4. So copy this code. Save the program. This is example 7. So I'm going to comment these 2 lines. I have declared a servo object to D4 pin, and this I'm going to write a for loop over here. So this will give you this will write the position to the angle. Okay. So it reads the current position and it rotates the current position. It writes the position to the angle. So I'm going to run the code now. Save the program and run the program. So I'm going to clear this one, clear Arduino. Servo has to be uploaded, like libraries and servo has to be uploaded. So I have copied the code and I have modified this library servos. I'm going to run the code now. So it will rotate based on the degrees, 0 degree, 36 degree, 72 degree, 108, 144, and it will go for 180 degrees. Okay. So if you rerun the code, I'm going to comment this line and I'm going to rerun this code. Okay. So it will start from the original position, and it starts incrementing from 0 degree, 32, 36 degree, 72 degree, 108 till it will go for 180 degree. Okay. So I'll explain you the code one more time. If you check here, this is the Arduino code. Arduino, and I have declared servo here. This is a for loop, and right position is to write the angle to the servo. So I have declared a servo here, and right position is to declare an angle has been passed to the servo. So this is the read position. So right position and read position are the servo commands, and fprintf is used for display. Okay. So with this, all the experiments are completed. So if you have any doubts, like you post the comments on the YouTube chat box or land@pantechsolutions.net. Today, 2 more days will be updated on the land@pantechsolutions.net. So with this, I close the session. Finally, I would like to thank you. Thank you once again. Thanks for coming. See